Okay, we're gonna keep continue with 1C. So today we're gonna talk about the odd and even functions. And odd function also we have the properties which is f negative x equal to negative fx. That's an odd function. And the graph odd function actually can rotational symmetries with respect for the regions. So which is the graph remains unchanged after the rotation of the 180 degrees about the region. Which means if you say f negative x equal to negative fx, that means it's odd function. An even function, which is the even function, has a property that f negative x equal to fx, so which is the not changing anymore. So which is f negative x to fx actually equals, and then that's the even function. Perfect. And then after that, we have the clearly we have a quadratics and a parabola, so we know is. So how to test out? Let's see the first question. Let x equal to a. So let's try with, x equal to negative a. Let's test out that equal to negative a to the power of quartic plus negative a squared. And it turns out that equal to a to the power of quartic plus a squared. And that actually equal to fa. So if negative a, function of negative a equal to function of a, that's even number functions. All right, and if how to test out the odd function? Same idea. Let x equal to negative a, and f negative a equal to negative 2, negative a cubic plus 7. So that equal to negative 2 times negative a quartic plus 7, and then that actually equal to the 2a quartic plus 7, and which is we can say is very the opposite, so which is that equal to f a negative. All we could do is substitution. Let x equal to -1, and then so x equal to -1, and then f -1 equal to negative 2 times negative 1 cubic plus 7. So that equal to 2 plus 7 equal to 9. Which means f1 equal to negative 2 plus 7 equal to 5. And then that's a minus, which is using the minus part. So that become 2 minus 5. And we can say that's not equals together. And then that means neither odd or even function. So let's think about it. What's that function then? Can anyone tell me about it? Perfect. All right. That's the some examples we actually can go through. So please let me know if you have any questions. All right, and then we jump on to piecewise function, define function. So we're going to sketch in the graph about the function f. So piecewise function actually is a different subset, and then the domain is called the piecewise-defined functions, and it's known as a hybrid functions, which is you actually can connect to each other and as your functions differently. Okay, so to draw this graph, we could just draw individuals. So first thing, negative x minus 1. And so we start with purple. So x less than 0. So which is when x equal to 0, that equal to minus 1. So which means when it's minus 1, it's a like open circle. And then you go into the negative sign. All right, and then second part, 2x minus 1 from 0 to 1. So when x equal to 0, it's still fx equal to minus 1. So which means the open circle become to the full circle. And then when x equal to 1, and that equal to 1 as well, so which is 1, 1. So which is from here, from negative 1, 0, 0 minus 1 to 1, 1. And then after that, half x plus half x greater than 1. So when x equal to 1, again, that's still in the full circles. So we don't have to change anything. And draw another part of the functions. You can choose any point, or we can say when x equal to 2, that equal to 1.5. Yeah, there you go. And then the range for the piecewise defined function is from negative 1 to positive infinity. So that's a y values. Okay, there you go. Sometimes you will say the graph like, you not actually connect to each other. They might do as going here and then start from here and then go here and then another one start from here. So they cannot always gonna connect. So make sure you will notice this one, okay? And during the class, I will show you how we use in the class to solve the piecewise functions. And that's for 1C, okay? So please make sure do some questions and practice during the meantime. And I will see you in the next one.